Hello everyone and welcome back. I'm Andrew. This video is part of an ongoing series on Agile software design where I'm discussing how the design relates to Agile software development practices. In this video I want to tackle the question of how we can do design efficiently, and the best way to do that is to do a demo. In the last video, the key question that came out of it really was, can you afford the time to do design? Surely this is extra time that we have to find and that's not going to help us. Really what we want to see is whether we can minimise the cost of design and maximise the benefit, and that's what this video is all about. So we're going to do a demo, but to do a demo we need a scenario. Our scenario is that we've been approached by an animal charity. They need help because they have no software at the moment. What they need to be able to do is catalogue their animals and where they are housed on their sites. It's a small company, it's about 30 people at the moment. They are looking to grow steadily. They have multiple locations and they don't have any single infrastructure, any combined infrastructure. So they want access to the application over the web. It's important that we minimise their infrastructure costs because their budget is not very big. And so our job is to design a solution for them. When we talk about design, there are really two types of design. There's upfront design and then per task design. The upfront design is more about choosing the starting architecture, which we assume will change over the life of the system, but we've got to start somewhere. I'm not going to be demoing the upfront design process. I'm just going to talk through what happened. Let's assume that's already happened. Well, the team got together and had a design discussion. This is what some people call whiteboarding. What we were doing was going through various potential architectural options for the solution in this case. Someone brought up microservices, and that's because these days regularly someone brings up microservices. It's a very trendy design architectural pattern which people are getting very excited about. Now, microservices is a discussion for another time. It doesn't give quite the benefits that people might imagine that haven't tried it already. But in this case, what we know for sure is that it's not appropriate. This is a small company and they have a limited budget. We need to keep the cost of the infrastructure down, so it's best that we keep things simple. Microservices is not applicable here. Therefore, what we're going to do is we're going to build a Blazor WebAssembly solution. This is a simple diagram that I've put together to give an overview of what we're going to be building. There's going to be two applications here. There's a Blazor WebAssembly application running on the client device, and then that's going to talk to a back-end built using ASP.NET over the web. The benefit of this is that we're using the power of the client's processing capability in order to minimize the infrastructure costs. Our front end is going to consist of a Blazor assembly user interface built using Blazor components, and our CSS files and that kind of thing will go in that project as well. Behind that, we're going to need some form of control. We're going to use the MVVM design pattern, and therefore in our UI control layer we're going to have a bunch of view models. The view models are going to talk to business objects where all our rules and the understanding of how to persist ourselves is going to go, and that's going to be built using a framework called CSLA. If you don't know CSLA, it's well worth having a look at. Our backend, our ASP.NET solution that hosts everything, is going to consist of an ASP.NET Core application. We're going to have our business objects, again using CSLA. They're going to offer a repeat of all the business rules, and they're going to talk to our data access layer, which is going to be separated out using the repository design pattern. That gives us better testability. It would also allow us to change data storage technology if we found that was ever appropriate, although that doesn't happen as often as people think. Now for the storage layer, I'm going to use a relational data store for the time being. It's what we know well, it's what we're very comfortable with. We're going to use SQL Server. We're also going to use stored procedures rather than ORM. Now, I know what you're thinking, that may seem very old-fashioned. Why on earth would we use something old-fashioned like stored procedures instead of an ORM? Well, the dangers and the pitfalls of ORMs are really a detailed discussion that are not for this video. That's something that I ought to cover separately. But in short, using stored procedures is going to give us a better security position. It's an easier justification from a security perspective. But really the main reason for doing it in this demo is to play devil's advocate. I want you to watch what happens during the demo and ask yourself at the end how an ORM would benefit in this particular scenario. Okay, before we dive in, it's important to realise that there are actually two things that will be alien to you here in this demo. The first one is an architecture that you may not know, may not understand fully, and even may disagree with. And the second thing is the tool and the process that we're going to follow using the tool. It's important to realise that this process works for any architecture, so I don't want you to get caught up in thinking about the architecture too heavily and mentally thinking up reasons why you wouldn't do it that way. I want the key takeaway of this demo is to be about the process, so try to concentrate on that. Okay, so I'm going to move on from the upfront discussion. Imagine we're in our first sprint. This is our first task and we need to do a design for it. How are we going to do that? Well, there's various potential techniques that we could use here. What lots of teams talk about is whiteboarding. They'll go back to the whiteboard and they'll draw some diagrams and they'll have a discussion. The problem with whiteboarding is that it's not really very detailed. We're not getting into the nuts and bolts necessarily. Or if we are, is this the right place to do it? Is design by committee always going to be successful when there's potentially too many people in the room? It's perhaps not the most efficient thing we could do. Whilst having a lot of people involved, more than one person involved in design is a good thing to get multiple opinions, multiple ideas. Two heads are better than one, as it were. It's not necessarily the most efficient thing to have everyone in the team in that design discussion for each individual task. Diagramming is another solution. Detailed diagramming, where we go back to our desks and use a diagramming tool. Diagrams are very important, and I strongly encourage you to be using diagramming in your design processes. However, the detail that we need to go into would get very cluttered in a diagram, so you won't necessarily get an appropriate level of detail. You won't get enough decisions onto a diagram or a couple of diagrams. So you probably need something else as well. Well, in my former company, we used to use Word, where we would create a design document writing down some detail. Now, it's important to realise that whilst in the early days we wrote these designs from scratch, what we moved to doing quite early on was not writing them by hand from scratch from an empty document, but instead we would copy and paste. We would reuse and adapt designs we already had, taking ideas that we were already comfortable with and including them in a new design. But Word has limitations in that what we really need to think about is the detail that varies depending on what it is we're designing. In other words, in some layers we may need particular questions answered that we don't need answering in other parts of a solution. So maybe what would be better is a custom piece of software made specifically for this job. I think so, and that's what I'm going to demo. Okay, so this is DesiGen. This is going to guide us through the process of creating a design. That's its purpose. So I'm going to choose to create one. I'm going to put it in a system called testing, which I've created. And the name of this is going to be, animal management. And I'm going to do something strange. I'm going to call this blank template. So the purpose of doing this is actually that what I would do is take this design, which is the very first one for this system, if you like, and I would use that as a template in the future. The way I'd do that is create this design, follow it all the way through to the end, and then I would clone it after I've finished with the design and give it a more appropriate name, and then I would change this original design to have less in it so that each time we create a new design we can use this as the starting point. Okay, so the first thing we need to do is enter a reference to the requirements that we're working with. This is just to remind us in the future what it was we were doing. It's possible that we've got a task tracking system with a reference number in it, and that's all we would require here. As it happens, I don't have that at the moment. The client has come to us without that being set up yet. What I've got is a document which I'm going to copy some text from, just so that you don't have to watch me type, particularly as I'm not very happy with this keyboard I'm using on this machine. This is not my normal machine that I'm using for recording on. So we can just paste in a piece of text just to explain what it is that we're doing a design for. We're actually going to do two tasks here. I would normally keep these separate in the real world, but for a demo it makes sense to run them together so that we're doing something a little bit more interesting. So there's effectively like a task 2 here, which is to add, edit and delete animals. That's what we're going to finish as part of this work. So that's just, as I say, a flavour of what we're doing. It's just to remind us in the future, if we come back to this design, what the design was intended to achieve. So the next step is to create any data structures we need. Now, data structures are simply collections of fields, bits of information that we might consider to be something that we want to work with together. So if, for example, we were going to create a table in a data store, like a relational database or something, then we could create a data structure for that. However, you can use data structures for whatever you want. They don't have to be persisted. It's entirely your choice what you use them for. So if you wanted to create like a data transfer object with simple getters and setter properties, then you could create a data structure for that and then never save it. Just use that for something like, for example, sending information to a web API or anything you like. So data structures are just like a general concept for creating collections of information that are related. So we're going to add a data structure. We're going to call it animal. And I'm going to use a template called ID and name. These templates are editable, but what they're doing is helping me create like a basic structure to which I can add things or change. And they're applying some naming defaults, if you like. The thing that I have chosen is appropriate for this particular scenario, or sorry, for our department really. Okay, so I'll create the animal data structure from that. It creates two fields, animal ID, animal name. Now, what we're trying to achieve is allow the charity to understand where animals are being kept. So we need to add a field in order to do that, and we'll call it, so we're going to call it kennel reference. That's probably not a great name for it, but it'll do for now. I'm going to make it a bit bigger so it can be 100 characters. I'm going to say it's a required field. So the data structure is going to include an ID field, which is like an auto-incrementing number, the name of the animal, and a reference as to where it's being kept. So that's the only data structure we need for this particular demo. So the next thing we do is we need to set up artifacts. So artifact is a fancy word for the sort of thing that we need to output as part of our design. So these are things like classes. We might include CSS files, JavaScript files, anything which we want to create as an output from our task. We've got two choices here. We can either add them individually, but that might take a while for creating a complete solution, which is what we need to do here. So we're going to use the add multiple option. And this shows us a bunch of templates which have already been created and are suitable for this kind of work. So I want a solution, I'm going to use CSLA, and we said we were going to use Blazor WebAssembly, so I'm going to use the Blazor WebAssembly hosted solution using CSLA as my starting point. It's going to ask me a set of questions which are applied throughout the creation of all the artifacts from this artifact set, this set of things that we're adding in one go. The solution name, so I've already said we're going to call that animal maintenance. And I'm going to put it in C demo animal maintenance. Oh dear. I did say I wasn't getting on very well with this keyboard. So I'm saying as part of my design where I would create this solution if I were going to do so. It's just a decision I'm making as part of my design. So it's going to ask me to confirm. There's no more information to enter on that screen. Now it walks me through the things which I have said as part of the setup of the template, the sort of things that I need to possibly customize as I go through the wizard. But in fact, because I created this template, I know that everything that's here is the way I want it to be, and it's taking information that I entered on that very first screen, those couple of bits of information, and it's using that to name all the things that it's adding. So there it is, it's added all the artifacts that were defined within that template, and there's quite a lot here. So we've created a solution at the top, we've got projects underneath that, and there are multiple projects. There's a WebAssembly project, all the things that we listed on that diagram, with a bunch of classes which just make this solution work the way that we would intend a basic solution of this type to function. Okay, so as I mentioned, I'm actually doing two tasks here. So the first task that I would normally do is to create the solution structure like we've just done, and then I would leave it at that, and that would be task number one. And the reason for doing that is that obviously what we want to do is we want to get all the rest of the team working on this as soon as possible. So if we did the design just for the structure of the solution and we finish the design, then we check that into source control, then people would be able to jump in and start doing their tasks as part of this sprint as well. But because it's a demo, I'm actually going to go a stage further. This would normally be a separate task, but I'm going to do it at the same time. And that is to do that edit that I mentioned at the beginning about adding, editing and deleting animals. So I'm going to use add multiple again. For my CSLA object layer, what I need is an object which allows me to edit an animal. But it's a very common pattern in CSLA that when you're creating an editable, you're also going to create a read-only root list and a read-only child, so that we can have a list of animals to begin with, and then we're going to have some buttons to say what we're going to do, and then at the point that we click one of the buttons, then we will have the editable created for us. I'm not going to go into the details of why we do that. It's partially to do with concurrency control and that kind of thing, but that's what we're going to do. So I'm going to choose the editable root, read-only root list, read-only child template. I'm going to put all of these in the objects project. This is the thing that's going to be our business object library, and I'm going to say they're going to be related to the data structure of animal, and it's going to walk me through the things it's creating. It's come up with a name which I'm going to change. I'm going to call it animal edit, just to make it clear that this is being used as part of an edit screen that allows us the opportunity to have multiple objects for different purposes if we want to, just by naming them that way. And I'm also going to change the authorization rules. I'm going to keep this application nice and simple and say that users can do all of the processes associated with animals, because there was nothing in the requirements that said that there are different subsets of users. If you remember our very initial diagram, there was only one user population on that system overview diagram. So we've not identified that there are different subsets, so we're just going to say that users can do everything. Then it's going to ask me about the read-only one. I'm going to do the same change with that. So I'm just going to say that there's only a thing called users, and the read-only should be fine. So those have been added as well. So that's our business object layer, which is going to be shared between the WebAssembly application and the back-end application. We're also going to need to do some form of data access. So I need an interface and a data transfer object, which is going to represent the contract that any implementation must fulfill in terms of data access. So I'm going to add that. That's going to be based on animal as well, and that's going to go in a subfolder of our objects project called data contracts. So I've very specifically chosen to put this within the objects project because that forces anyone that creates an implementation of data access to reference that project. And what that means is that you can't accidentally put the reference the wrong way around. You're not allowed circular references. So by putting the contracts within the same library as the thing that uses it, stops us accidentally making a mistake of referencing the implementation anywhere. So I can add that. It's going to ask me a bunch of questions, but those are fine. So that's the definition of our data access, but it's no implementation. So we're going to add an implementation. This is where I'm going to do the thing that people are going to question, which is I'm going to use store procedures. So we're using the repository pattern. I'm deciding that I'm going to use store procedures rather than ORM, and I'm going to create all the objects, all the artifacts associated with that now. So these are going to go into a project called Data Access. I could call it dataaccess.SQL Server because it's an implementation for SQL Server that I'm doing, but I've just called it Data Access on the assumption that there is only going to be one Data Access implementation. It is common to think that you might change. The reality is that once you have a system, your ability to change your data store technology is not all that straightforward. It would take time to do. Now we're doing the architecture so that it's possible to do that, but the likelihood that we will actually do it is quite small. So I'm going to just ignore in terms of the naming that there might be another implementation in the future. It seems unlikely. The main reason for following this pattern is that it disconnects our data access so that we're not trying to access a data store during unit testing unless we want to. So what it's going to ask me is where to put the store procedures associated with the animal structure. So I'm going to put those in a special place. I've got a project called Data Storage. This is a special type of project which understands the idea of defining a SQL Server database. And it has a structure which is fixed by that, that project type, if you like. So I'm going to put the store procedures into the folder called store procedures, which already exists. The table is going to go in tables and again is related to animal. It's going to ask me a couple of questions about what I want to call things. The database name should probably be called animal maintenance. That seems like a reasonable name for it. And everything else we should be able to just accept the defaults. So what we've done is we've done our business objects, we've done the data contracts, we've done the data access implementation. So we've done the sort of bottom bit of the stack of the structure, if you like. We haven't done anything about any form of user interface, so that's what we'll do next. So what we want to do is we want a manage list edit component, view model, and a test for that view model. The view models contain complex logic about how the user interface should work, so we're going to create tests for that. Again, this is a pre-built template. So where am I going to put my Blazor components is the first question. Well, so they go in the components folder. So they're going to go in the WebAssembly project. I've chosen to put them within that project. Could put them in a separate project, but I've just chosen to put them within there as part of this structure. So Blazor components are going to be associated with animal. The view model is going to go in a separate project. I'm keeping my user interface control separate on purpose, keeping it out of there in a separate project in case we ever change the user interface technology. The UI technology is the thing that changes fastest in the industry. So separating those two out, not having code behind, if you like, is a good thing. So I'm going to put that in a separate project called UI control. That's where our view model is going to go. And then the tests, somewhere here, we should have a unit test project. And that's where I'm going to create my, my tests for that view model. It's going to ask me questions about how to do things. Authorization, we've said, is about users. So I'll change that one. Editable object name, if you remember, we called it animal edit. Everything else should be okay. Our view model name looks fine, and for the final thing that we're creating, the view model, it needs to know the name of the editable object type again, and if you remember, I called that animal edit. So I enter that, and for the tests, I think we can choose the defaults there. So that's created a bunch of stuff for a user interface layer for us, and the user interface control which sits behind it. So we've done data storage, which is the definition of the implementation of the data store. We've done data access, which is the way to access data. We've done the contracts, we've done the business objects, we've done the view model that sits above that, which manages how the user interface works, and we've done the user interface. So that's all of the artifacts that we need for this design. So we can move on. Now, edit references. This is where I would add references to other things which are relevant to the design. So a good thing to add here would be references to our diagrams that we created. I'm going to skip that because this is a demo, but that's the sort of thing that I would add there. Possibly an architectural overview document. If I've created one of those, I would add a reference to that. So the next question is about authentication. Are we doing anything with authentication that results in a risk? So what happens by default with this particular template is that we get a sort of fake authentication mechanism, which means that we don't have to keep logging in. So that is obviously a risk in terms of the real world. We wouldn't want that to go live. So I'm going to just put a piece of text in that says that this is the case, that there's some fake authentication in place for testing purposes, but that we need to be aware of this as a risk were we to take this beyond the demo stage and actually use this. Next is authorization. Well, more or less the same thing is true there. Authorization would work, but for the fact that authentication is fake. So again, I've got a piece of text which is just a warning about that, just a reminder to me if I come back to this in future. What did I say about authorization? Now, really, generally, you wouldn't need to put very much in either of these boxes because your authorization and authentication decisions are probably better in like an architectural or system overview document, if you like, describing how you're going to do your authentication once you've made the decision. You don't have to decide it straight away. And I would therefore normally just put in my designs that there are no changes or that there are changes. If there are changes, then it's risky, and that's why the question is being asked is, are we doing anything here which might be considered a risk? Please think about it. Okay, I've thought about it. There's nothing here which is significant. So the next thing is, what sort of risks are being added to the solution as a result of the task that we're doing? Think about the functionality that we're adding and whether that adds any risk. Well, the functionality itself is pretty straightforward, but because this task is about not only doing the edit, but also about creating the initial structure, there are some risks associated with using this sort of very basic solution template that I've created. Number one, the one I've already mentioned, is an authentication bypass. So I'm going to add some risk declarations just to say this is a risk and this is what I'm going to do about it. I've got suggestions to help me to think about these sort of things. I've got one called authentication bypass. Got potential mitigations down here, but I'm actually not going to mitigate it. The point is that this is a demo, so we're not going to do anything about the risk. We're just going to state that it is a risk. So I'm not going to choose any of these ones at the bottom. But in the description, I'm going to put a piece of text which just says there is no proper authentication and it's faked. If we were to do anything with this in the real world, we would need to do something about that. So authentication bypass is a risk, and we have mentioned it and we've said what we're going to do about it. So the next one is we're using CSLA, and we're actually using CSLA 552 here. CSLA 6 is not quite ready to go, so I'm still using a sort of older version of CSLA. CSLA includes a thing called the data portal, and the data portal in versions prior to 6 contains ways to add protection to it, but it doesn't contain any default protection in that as part of the solution. So that's a risk. I've got that. I've added this. This is like a custom addition, if you like, in terms of the risks that I can choose, because this is all editable by the user. So I've added this one to say I'm using the CSLA data portal. Again, I've got potential mitigations, which I'm going to ignore because I'm not going to mitigate it really. I'm again just going to add a piece of text that says in CSLA version 552 the data portal includes extensibility points for securing the data portal endpoint, but the functionality to perform the appropriate reauthorization, revalidation and exception sanitization are not enabled or included by default. There is nothing in the box that helps us do this. We would have to write a solution for this as part of our code if we needed to do anything about it. However, I've said this risk is acceptable for a demo. However, this would need to be more completely addressed if we were to reuse the design. So that's that risk identified and details about what we're going to do about it, which is basically nothing. And there is a third one, which is that there isn't any logging as part of the solution template because everyone's logging solution is different. So because this solution template is intended for more than just my own purposes, I haven't included any logging out of the box. So we would probably need to do something about that so that we understand how the system is working and we can investigate if anything goes wrong. So there is in the list insufficient exception handling. That's a pretty good description of what's going on here because there sort of isn't really any exception handling. It won't necessarily throw exceptions to the end user, at least if we compile it in release mode, but it isn't really doing anything about exceptions properly. So again, no, going to ignore the mitigations in this case, and I'm going to just paste in a piece of text explaining that I haven't really thought about exception handling very much and that there's no logging in place. As such, there is a chance that exceptions might be exposed to parties outside of the company or the charity in this particular case, and that exceptions could contain sensitive information. So if we were to allow an exception to leak outside of the application, it could give something away that an attacker might be able to use against the system. So for example, it might contain the name of a stored procedure, the name of a table, the name of a database. It could contain all sorts of things. So we don't really want to expose that sort of information. I've also said that the lack of logging, because there isn't any really, makes it difficult to identify when the system is not working correctly, which might allow an attacker to gain access to the system without being detected. So there is a separate category of risk, which is about the fact that you ought to have monitoring in place to determine if the system is misbehaving in a way that you don't expect. I'm going to sort of run these two things together in this particular case, but we could log that one separately. Again, these risks are acceptable for a demo, so I'm just accepting the risks rather than necessarily mitigating them in this particular case. Now, if this were a real-world task, I might need to do a bit more than that. But that's good enough for now. That's our risk declarations dealt with. So the next question is security categorization, excuse me. So how overall, given the decisions that we've documented about authentication, authorization, and the risk assessment that we've done, how significant a risk is this? And is there anything that we need to do about changing our processes to cater for the fact that we're doing something which is unusually risky? In my previous company, what we did was we had a sort of 3-level by default concept within our processes, which was to say, ideally we would do a code review on everything, but that it wasn't mandated for a standard task by any means. You know, it'd be nice, but it wasn't necessary. If something was a little bit risky, then we would say that it needed to be code reviewed by a senior developer. And if it was security related or particularly risky, then it would need to be code reviewed by me, the architect. In this particular case, I'm saying I consider this development task to carry a low risk because it's part of a demo, and the system under design is not intended to go into production. So I don't intend to use this design for anything that's real world. But I've just put a reminder that anyone that reuses this design, that uses it as a basis for doing something else, might need to think about the things that we haven't thought about. But in this case, there's nothing particularly risky because we haven't made our authentication authorization decisions yet. We're not doing that effectively as part of this task. And the editing of an animal is not a particularly risky activity. It's just bits of text. So I'm not going to trigger any special processes as it happens. There's no one here with me today to do any special processes with me, like work with me to do a code review or anything. And the final thing is data retention policy. So what we're going to state as part of a data retention policy is, have we thought about whether we need to delete transactional data that there might be a lot of during the life of the system. So in this particular case, animal is a transactional bit of data, so there are going to be lots of animals recorded on the system, and we ought to think about it in 2 regards. One regard is GDPR. Is there anything which is personally identifiable which is being added as part of this task, and what are we going to do to obfuscate or delete it in the future to avoid personal information being held indefinitely, which would not be allowed. But the second thing is, if we were to build a system which you were allowed to enter data into indefinitely, but didn't ever do anything about it, then eventually the system would become full at some point. All the electrons in the universe would be used up, and there would be no more electrons to record any more information. So it is always worth considering, do I need to do something about deleting data from this system? Is it going to get big enough? Well, we've said that there are 30 users, and those 30 users are mainly looking after animals and not entering data in the system like every second of the day. So at this stage, there's not a lot of information. And it is perfectly acceptable for us to say we don't have a data retention policy defined yet. It's not part of task 1. It's on the backlog. It will be prioritized when data retention becomes relevant. So it doesn't matter that we're not deleting data to begin with in any system. There is a point at which we need to start deleting it, and that's when the task for doing that would be prioritized. So at this stage, I'm just going to paste a piece of text in, says it's not been defined at this stage. Because it's a demo, there isn't going to be any real data anyway, so that data wouldn't need obfuscation or deletion for the purposes of because it's sensitive in any way. And in terms of dealing with the data volumes, I'm just going to delete the database when the demo is complete. Okay, so at that point, our design of this task is complete. So what does the tool help us to do next? Well, so the first thing it can do is it can create a document for us. We can create an export of the information that we've entered into a Word format. The benefit being that we can then store that on the network as something which we could go back to, that we could give to an auditor to prove that we did a design if we wanted to. It's also a document which you could provide to someone if they were going to do a design review for you, which is the next thing we're going to talk about. So this details all of the decisions that were made, all of the artifacts that we identified that we needed to save, all of the risks that we identified and the mitigations that we detailed, and all of that stuff. Everything is just output into a Word document, and then I would do file save as and save it as somewhere suitable so that I could go back to it in the future. Okay, so the next thing is to update the status. The design in the configuration, the way my system is and how it comes out of the box, if I remember rightly, is that at the status of in design, which is what this design is at the moment, you can't actually do much else. So we need to make a decision about what needs to happen next. And I would update the status to make that decision. So I could pass this to someone else to review the design for me. This is the point at which I would get multiple heads involved. I have now made lots of detailed decisions about what I'm going to do as part of this task. And under certain circumstances, it's beneficial just to bounce that off someone else and say, what do you think about these decisions that I've made? Do you think this makes sense? So this is like a teamwork, and getting people involved to make sure that good decisions have been made, that we haven't missed anything that might benefit the system, if you like. So I could pass it to someone to do a design review. In this case, as I mentioned, there's not anyone here to do that, so I'm just going to mark it as ready to develop. And that creates, that enables a button for me called Generate Code. So what's that all about? Well, in this design, within this application, what we've done is we've entered the data in a structured way that says how we're going to build the system. We've entered information about the data structures and all the artifacts. So the Generate Code button allows me to create a starting point for my development. So it's created all of the artifacts for me that were set in such a way that they were needing to be created, which in a brand new design is pretty much everything. And the result of that is that on the hard disk on my machine, it's created a Visual Studio solution, because that's what I'm working with, and all of the projects and all of the code associated with all of the artifacts that we designed. So there's our editable object and our read-only and our list, for example. And similarly within data access, it's created a bunch of code. Now, this code doesn't work. That's not really the intention, that we would just generate all the code and not have to do development. But it gives us a starting point. It's done all the boring stuff for us of creating objects with properties that are, defining all the bits of data that we're capturing as part of this development task. So we still have to do some work. In particular, in this case, we have to stitch it together, because although the data is structured, the parents don't know about the children. The other way around is a little bit more true to say, that the children of things know a bit about their parents and that they're related in some way, but the parents don't know about the children. So in particular, the solution doesn't know what projects are underneath it in the code form that we've generated, if you like. So we'd have a bit of fixing up to do, and then some customization, because obviously from what we've created, we can't create every single thing that we want. We've taken a guess at the sort of code that we might want and created that as an output. So the benefit of that is that we've just won back a bunch of time that we would have had to spend in a development task, because we've created the structure of everything that we needed. We've created quite a lot of the code that we would need in order to complete the development. Now, I'm not going to go into actually doing that bit of development, because that's not part of design. So I'm not going to cover that in this video. I think we've done enough to get the idea of what the tool is about today and the process that the tool is helping us to achieve. I'm going to turn what we've created here into a working demo in a separate video. So there's a link to that in the description. Okay, so what we've seen there is a demo But it's important to realise that that's an idealised scenario. We had templates for everything we needed in that particular case, and that won't always be the case. As always, development is more complicated than leaving it to a computer. If there's a scenario where we have no template, then what instead we would do is use an empty template of an appropriate type, and then explain in the customization section for that artifact what needs to be built. And perhaps we don't need to go into a lot of detail, but just some summary that reminds us what we had in mind for that particular item. It's important to remember when thinking about the demo that tool works for any architecture and it can generate any language. You just need to set it up to do so. In order to do other architectures and languages, what you need to do is develop templates for that, and that's not particularly hard. Templates consist of JSON files that explain what the template is and a text file which is used during generation. Okay, so in summary, what have we done here? What is the demo shown us? Well, hopefully you realise that this is a pretty efficient process. Our design time was won back in development because the design tool was able to do a little bit of the setup of the development task for us. We have consciously made decisions rather than doing so unconsciously as part of our process. And what's more, we recorded those decisions, which helps us with accountability in the future. The design time was minimal, and thus the payback on that design should be short. The process also encouraged us to consider the risks of what we were doing. This helps reduce the potential for vulnerabilities being included in the software. But remember that doing that risk assessment is not just about checking checkboxes, it's about actually protecting the interests of all the stakeholders. Okay, we used templating as well, and that helped us to reuse patterns and practices that work for us. This helps reduce the potential for bugs. It opens the design to more junior team members because it reduces the options available to them to the things for which we have templates. And it helps us to achieve greater consistency because the templates encourage us to use something which we've already done before. Design is also an opportunity to get feedback before building something because two heads really are better than one, and potentially more than two, but perhaps not as many as the whole team. I think there are benefits to recognising design as important. Making decisions needs to be conscious, not unconscious. Formalising design in your working practices can bring greater benefits than you might imagine, and I've had a lot of success with this approach. So the question we asked was, can you spare the time for design? And I think the answer is yes. But don't just believe me. Why don't you try it for yourself? I'm very happy to announce the public launch of the tool you've just seen. The tool is entirely free and is my gift to the industry. There is no advertising, there is no registration, there's no sign up. You don't need to tell me who you are, give away your personal information. I don't want it, it's a GDPR nightmare. There's a companion website for this video series, and that is at getdesigning.notstandard.com. getdesigning.notstandard.com. On that website you'll find a link to the docs site for the tool. Download it and give it a go. Note that the tool is not yet open source, but I am intending to work towards that. Note that the documentation site lists some prerequisites for the tool to work. Please check those and bear those in mind. It's also worth mentioning that the installer is not code signed at the moment. That's because there's a cost to code signing, and I'm not going to pay the money for the code signing certificate until I know that there are people that are interested. So my hope is that you will try the tool. I think you're going to like it, but give it a go. My hope is that you will use it to improve your working practices, and that in turn that will ensure that you protect my personal data better in the systems that you develop. I'm kind of getting a bit tired of my personal information being at risk from vulnerabilities in other people's systems. Okay, so that's it for this episode. In the next episode, I'm going to cover when to do design. I'm going to talk about when within the process we do it and when it's not applicable. Why don't you join me for that?